Hi everyone. In this video, we are going to continue to talk about lines, and we're specifically going to talk about lines that are in the point slope form of their equation. So with this, you'll be able to graph lines and write equations in point slope form instead of slope intercept form like we did before. So before we talked about slope intercept form of a line is the form where you can see the slope, which we use the variable m to represent, and the intercept, specifically the y-intercept, which we use the variable b to represent. Okay, so slope-intercept form of the equation was or is y equals mx plus b, where m is your slope and b is your y-intercept. Okay, which is a super useful form of an equation, but up until now that's the only one we've used, but it's really not the only way to write a linear equation. Okay, so what we're going to talk about today is one other way to write a linear equation. So we're going to write that down here. It's another way to express a linear equation, or to express the equation of a line. Okay, and it's important to note that the point slope form and the slope intercept form are equivalent forms. So you can write the same line in both ways. They're just different pieces of information given. So in slope intercept form, you can look at it and easily see your slope and your intercept. That's why it's called slope intercept form. Now in point slope form, you're easily going to be able to see your point and your slope. Okay, so just like the slope and intercept form are in this equation, a point and the slope will be in point slope form. Okay, so point slope form looks like this. Okay, you have the variable y, just like in slope intercept form, but from y, you're actually going to subtract your y coordinate. So I'm going to call that y1 for like the first y coordinate. It really just differentiates between these two y's here. Okay, so it's y minus your y coordinate is equal to your slope, which we still use variable m, times parentheses the variable x, just like you have here, minus your x coordinate. So that's what point slope form looks like. Let's go ahead and label what these different variables represent. So m here, just like in slope intercept form, is your slope. Okay, m is always slope, m stands for move. Okay, now you have your y1 and your x1, which you want to say that as I said it when explaining it. It's your y coordinate and your x coordinate. So this is the y coordinate of a point on the line. I'm abbreviating coordinate and point on the line you're writing the equation for. And this would be your x coordinate of a point on the same line. Okay, so anytime you're using point slope form, when you look at that, you can find a point and a slope. Kind of similar to slope intercept form, because when you found B, your y-intercept is just a point on your line, but it's a specific point. It's a point that's on the y-axis. Whereas here, when you're plotting point slope form, you'll just pick any random point on the coordinate plane to plot based on your equation. So I could plot this and then rise and run from there and still get the line without having the y-intercept specifically. Okay, so when you do go ahead and find that important information, you're going to find your slope and you're going to find a point, and your point will be x comma y, but we called x x1 and y y1. Okay, so these are the two different things you can find from point slope form. Okay, I know that we spent a lot of time on slope intercept form, and now it's like, oh, why do I have to learn point slope form? But they're useful for different things. So if you have a y-intercept, it's easier to write it in slope intercept form. But if you have any other point on the graph, point slope form is actually easier. And since there are more points on the graph that are random other than your y-intercept, I'm going to have to say that, as a teacher of Algebra 2 and geometry, I use point slope form way more than slope intercept form. Okay, so it's useful to find multiple ways to do something just in case you're given different information. I'm going to give you a few examples here. So it says write the equation of the line given. Okay, this is just like when we did slope intercept form, but I want you to use point slope form when applicable, aka when we have a slope and a point. Okay, so if I have a slope and a point, you're going to use point slope. Makes sense. Math people aren't super creative with their names. If you have a slope and a y-intercept, then you may want to use slope-intercept form, which we'll get to. First thing I always do is I write down the general form of the equation, so I have that structure laid out. So I write y minus my y-coordinate equals my slope times x minus whatever your x-coordinate is. Okay, then I recognize that I have my slope here, and slope is m, so we know our slope is 7. We can take the m and substitute it in a second. Okay, then I have a point, which a point is always written as x comma y. Okay, but we called the coordinate y1 and x1, so I'm going to call this point x1, y1. And now you can just substitute them in where they belong. So my m here is going to go into m. My x1 is going to go into x1. And my y1 is going in for y1. All you have to do is substitute once you identify the information. So it's y, and then you subtract whatever your y-coordinate is. So your y-coordinate is 4. Okay, then you plug in your slope for m. Then it's going to be x minus your x-coordinate. So it's actually x minus my x-coordinate is also -1. So you have a double negative there. And then we can simplify. Since we have a double negative, that should be a 4. Since we have a double negative, that's the same thing. X minus -1 is equivalent to x plus 1. And you can leave your equation of your line just like this. You don't have to isolate the y to put it in y equals mx plus b. Make it easy on yourself and just leave it as is, because this is another way to express the equation of a line. Okay, if you wanted to go backwards and say I gave you this problem here and said what is your slope and what is your point, you could say, okay, this number is the slope, so my m equals 7. This is my point, so my point is going to be, oh wait, my point is actually -1,4, as we saw over here. Okay, so one thing I hope that you notice is that even though it says x plus 1, your x-coordinate was actually -1. And even though it says y minus 4, your y-coordinate is actually +4. So these coordinates are really going to look the opposite of what they actually are. And that is because in this original equation, you had a minus, and minus makes it the opposite. So it was y minus +4. It looks like y minus 4. This was x minus -1, which actually turned into x plus 1. Okay, so keep that in mind. Even though it looks like -4, your y-coordinate is +4. Even though it looks like +1, your x-coordinate was actually -1. Okay, I want you to try this guy on your own. Remember, I always start by writing out the general form of point slope, and then I plug in the important information. Okay, try this, see what you get, and I'll come back with the answer in a moment. Okay, if done correctly, you probably got this. Maybe you simplified that and said y minus 0 is just y, and you rewrote it like this. Okay, color coordinated so you can see. So slope gets plugged in for the green for m. Your y-coordinate gets to go in for y1. Your x-coordinate goes in for x1. So you get something like this. And I actually gave you an x-coordinate of 0 just to prove a point that if you simplify this, this looks very similar to y equals mx plus b. In fact, if I actually distributed this -1/4, it would be y equals mx plus b. Okay, so that would be this equation. And the reason I show you this now is because I want you to know that this equation here and this equation here are equivalent ways to express the exact same line. They're just two different ways to do it. Okay, so while this is a perfectly good answer, I just wanted to point out that they are interchangeable. Okay, now one is easier than the other. Like this was much easier since you were given a point and not this y-intercept to write it in point slope, but you can also write it in slope-intercept form. Okay, whereas this problem, when you're given a slope and a y-intercept, well, then you may just want to go in, plug your slope in for m, plug your y-intercept in for b, and that would be much easier than point slope. So it really depends on what information you're given, which equation you're going to use. Okay, so point slope, use the point in the slope. Slope and intercept, use slope intercept. It makes sense, hopefully. Okay, we're going to kind of go the opposite way now. So now you have the equation. I want you to identify the slope and the point of the equation. We'll call that x1, y1. Okay, so thinking about point slope form, I'm actually going to rewrite this just above it. Remember, it looks like this. Y minus your y coordinate equals your slope times x minus your x coordinate. Okay, so wherever's in front of the parentheses is your slope. Whatever's attached to the y is going to be your y coordinate. Whatever's attached to your x is going to be your x coordinate. That should be intuitive. Okay, so your slope is then just what it looks like, negative 2/3. Okay, the y coordinate is going to actually have something to do with this minus 1 because it's attached to the y. The x coordinate is going to have something to do with this 5 because it's attached to the x. So it doesn't just go left to right here. Okay, but remember what I said before, that even though your point here was negative 1, in the equation it looks like positive 1. So that's actually going to be the opposite sign. So your point looks like positive 5 for the x coordinate. It's actually negative 5 for the x coordinate because there's a subtraction sign that made it the opposite here in the original equation. Okay, your y coordinate looks like minus 1, but the minus comes from the equation, not the coordinate. So it's actually plus 1. So the slope of this line is negative 2/3. The point that this line passes through is negative 5,1, which I'll show you an example of why that's important is because that helps you graph it. So in order to graph the line, you need to start with some point. And in slope-intercept form, usually plot the y-intercept, and you move with your slope from there. That's how you get the line. Now in point slope, it's kind of the same process, but instead of plotting the y-intercept first, you're going to plot whatever point you have on the line first. So that's going to be your x1 and your y1, whatever point that gives you. So first thing I always do is identify my information, then I move it to the graph. So here, let's go ahead and write point slope again. It's y minus your y coordinate equals your slope times x minus whatever your x coordinate of that point is. So this is going to be your slope, lining them up real nice. This is going to be your x coordinate, and this is going to be your y coordinate of that point. So your slope is negative 2, which remember is a rise over run from our previous learning. And your point is going to be not negative 6. The negative comes from the subtraction in the formula, but positive 6, not negative or not positive 4, but negative 4. Okay, that's the trickiest part here of point slope form. Again, the reason why it's positive is because it's really minus negative 4, which when you subtract a negative, it's positive. Okay, so now that you have those pieces of information, we can plot this the exact same way we did slope-intercept form. We're going to start by plotting a point, but we don't have the y-intercept to plot, right? We have this point. So you're still going to start with a point, but that point is 6 on the x and negative 4 on the y, which would be right here. This is the point 6, negative 4. And then your slope tells you how to move from that point. It's a little bit different than plotting here and moving from there. Same concept though. You're just going to start at your point and you're going to rise and run from that point, which in this case, let's write as a fraction because that makes it easier. 2 is the same as 2 over 1. And you're going to go in the negative direction, which means your line should be decreasing, like you're skiing downhill on a mountain if you read that like a book. Okay, so I could go up to over 1 and be here. Okay, or you could go down 2 to go negative and over 1. But either way, your line needs to be downhill. You could keep repeating that. You could keep going if you want. You don't have to plot this many points, up 2 over 1, just to get a more accurate picture of the graph. But remember that lines go infinitely, so you throw some arrows on the end, and then you don't have to plot those points. Okay, so very similar to plotting slope-intercept, except first you're going to plot your point. Whatever point you're given. So it could be any point on the graph. It doesn't have to be on an axis. It could be here that you start. It could be here. It could be here. Okay. Then you're going to use your slope to move from there. So just slightly different than slope-intercept form. You're moving from a random point rather than moving from an axis. Otherwise, it's not too different. Okay, so to summarize, this is slope-intercept form. There it is. That we used before. This is point-slope form. Honestly, I use point-slope form a little bit more in higher level math than slope-intercept form, so make sure you get to know this pretty well. If you have any questions, let me know.